Well, today we're going to be covering section 3.05, the remainder and factor theorem. I don't think yet you're going to find these to be too overwhelming. I think that it should be pretty straightforward. Let's just go ahead and dive in and talk about what the remainder theorem is. And I've actually already alluded to it in the synthetic division and synthetic substitution lesson. And so let's go down here and let's look at this mathematical language that we have before us. So it says here that the remainder theorem says for any polynomial p of x, that's just the name of the polynomial, okay, and a number a, the remainder of dividing p of x by x minus a. So like if a is 1, right, then it'd be x minus 1. Get the idea? So the remainder is, if you take any polynomial and you divide it by x minus a, notice that the a that's in this location, I should say it this way, is the same as finding p of a. Now, you might be going, okay, that's great, lots of mathematical words there. I need a second to digest that. Let's use this. It says now we can use synthetic division to help us find values like p of 1. And this is ultimately what we're looking at. Okay, since if you dividing p of x by x minus a is the same as finding p of a, then you can use synthetic division, and whatever the remainder is the same value. So let's take a look here. Well, let's write this into our notes. So we say that we're going to do that. So here we're going to use, you can use direct substitution. So I'll say use direct, or more importantly, synthetic substitution. I'm kind of running out of room here, and I know I'm going to write below it. So ultimately, what's going to be really cool is we're going to be graphing in the next unit. And so we're going to use this to help find points on the graph. So I'll say we will use this fact to find points on polynomials to graph. Now, this is actually going to be just a repeat of what we did. We did synthetic substitution, okay, because it is synthetic substitution. We just didn't introduce the actual remainder theorem. I thought it would just be a little bit much, so I save it and do it now, and I'm going to teach it with the factor theorem. So if I want to evaluate here p of x, right, which is x cubed plus 2x squared minus 4x minus 8, when x is 2, okay, well that means that I could do this with either synthetic division or with direct substitution. So let me do synthetic division first. Substitution. And then we'll also verify it with direct. Okay, so we're going to find p of 2, right? Is our goal. So I'm going to create my window. And if you remember correctly, we're going to take the 2 here, and we're not going to change it at all. Whenever you're given the value of x, like they tell you x is 2, x is 10, x is -5, x is a half, you always write it as you see it in the window. Now, if they give you the factor, right, x minus 2, that's when you change the sign and you bring it in. When you're given the factor, you change the sign. When you're given the value, you just use it. So we do want to ask if there's any missing terms. The highest power is a cube. Is there any missing terms? Just count down, right? I see a power to the second. I see a power to the first. I see a power to the 0, which is the constant. So I'll just write a note here that to remind us that we always look for missing terms. So no missing terms. So I can bring down the coefficient. So 1, 2, -4, -8. Leave space below all of those. Okay, and this is what I know, right? Before I even get started, whatever the value is that I get in this location as the remainder, this will be P of 2. So drop the 1, and then do 2 times 1, which is 2. Add going down, you get 4. 2 times 4 is 8. Add going down, you get 4. 2 times 4 is 8. Add going down, you get 0. So P of 2 is equal to 0. Or we could write it like uh, 2, 0. And then down below here, I'm going to do now, right, or direct substitution. So I'll do here. So here. So just as a review, right, the equation written above is P of x is equal to x to the third plus 2x to the second minus 4x minus 8, and we're going to find P of 2. So that'll be 2 cubed plus 2 times 2 squared minus 4 times 2 minus 8. 2 cubed is 8. 2 squared is 4 times 2 is 8 minus 8 minus 8. Do you see that P of 2 is 0? So we can evaluate either way. We can find that coordinate by doing synthetic substitution or direct. Now you're going to probably guess on the test I'll require you to use synthetic substitution since it's new. Okay. So let's just take a quick peek at the next one. I am going to just dive right in here. So in the window, I'm going to take this -1, and remember it's the same, so you put it there. Are there any missing terms this time? The highest power is 4. Oh, it's missing an x cubed, huh? And then a square. Oh, it's also missing an x. You see it's missing 2 terms, you guys? Is it missing it? No, it's got the constant. So I think we're good as long as we keep in mind those missing terms. This is a leading 1 here. Okay, and then we're missing the x cubed, so I'll put a 0. Then we have the negative 13. Then we're missing the x, and then we put in the 36. So and then remember, right, we know that whatever we get here is going to be p of negative 1. So I'll drop the 1 times negative 1 is negative 1. Add going down, you get negative 1. Negative 1 times negative 1 is positive 1. Add going down, you get negative 12. Negative 1 times negative 12 is 12. Add going down, you get 12. Negative 1 times 12 is negative 12. Add going down, you get 24. So we can say that p of negative 1 is equal to 24. Okay, or, right, we can write that as negative 1, comma, 24. No, hang on one second. Negative 1 equal to 24 or negative 1 comma 24. So with that, let's go move on now to the factor theorem. Okay, so in order to do the factor theorem, we need to make sure that we have a basic understanding. Okay, what do I mean when we talk about factors? So if I ask, what are the factors of 60, you would give me numbers that multiply to give you 60, right? Like, how about, well, give me factors of 60. What are numbers that multiply to 60? 3 and 20. Good. What's another one? 6 and 10. Another one? 15 and 4. Good. There's 2 more. 10 and 12. No, 5 and, yeah, anyways. 5 and 12. Oh, there you go. 5 and 12. Got it? 1 and 60, right? And 2 and 30. I think that was the other one that you missed. So I'm going to write them down here just so that we can see them. But you guys obviously understand what a factor is. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and then 6 and 10. What happens when you divide 60 by one of its factors? So what's 60 divided by 30? 2. What's 60 divided by 3? Good. What's 60 divided by 5? What do we know when we divide 60 by one of its factors? You get the other factor. Do you get a remainder? I like that, though. Get the other factor. So I'm going to put here, it goes in evenly, right? Right, meaning that we have no remainder. This is the big part here. Okay, or we could say the remainder is 0, right? Because technically it does have a remainder, it's just 0. So therefore, I'll put here, when doing division, if the remainder is 0, the divisor is a factor. Can we say that? So, and then to put what the other students said, because I think it's good, when you divide a number by a factor, I'll use the hashtag to abbreviate number. So when you divide a number by a factor, the result is also a factor. Okay, so notice here, I have this, it says when you divide 60 by one of its prime factors, prime number, right, is a number that can only be divided by one in itself. The resulting number is another factor, not necessarily a prime factor, that can be factored further to find more prime factors of 60. So notice here, if we take 60 and we divide it by one of its prime factors, can I do 2? What's 2 is prime? Do you all agree? Okay, so what's 60 divided by 2? Okay, 30. So is 30 a factor of 60? Is it? Yeah, it sure is. Okay, so I'll say here another factor of 30, of 60, sorry. But it's not prime. So because it's not prime, I can divide it again. Now I notice that 2 goes into it again, into 30. So instead of breaking 60 down further, I'll break the 30 down. So 30 divided by 2 is what? 15 again, right? That's another prime factor of 6, not a prime factor of 60. And then 15 is, what can I break that down to be? Good. 5 and 3, I'll write it 3 and 5. So those numbers, right, 2, 2, 3, and 5, are the prime factors of 60. Right? 2 times 2 times 3 times 5. Notice what is, let me box this. What is 2 times 2? 4, good. Sorry, I'm trying to find my pointer. Where's my pointer? There it is. So 2 times 2 is 4. What's 4 times 3? And then what's 12 times 5? Okay, so notice the prime factors multiply to give me the 60. Okay, are we good with that? Get the idea, reminding you of what a factor is? Okay. Factor theorem then, let's dive here. So let's look at the math wording here first. It says, given a polynomial p of x and a number a, right? If p of a equals 0, wait, remember now, we know that when it says this, right, p of a equals 0, we know that it's the remainder equals 0, right? Okay, so if you find p of a equal to 0, then what that means is that x minus a, right, is a factor, right? Because it divides evenly, right? It doesn't have a remainder. Okay, so notice here, right, it's x minus a here, but it's a here. Okay, so it's the opposite because we're pulling from a factor, x minus a. Okay, so let me show you what that means. So example 3, it says given given what f of x is right here, it's 3x to the third minus 4x squared minus 9x plus 10. Show that x minus 2 is a factor. So if we're going to show that it's a factor, we got to just divide, right? And when we divide, the remainder has to be 0. And then find the remaining factors. Oh, look at this. It's asking us to do two things in this one, okay? So first, we need to show that x minus 2 is a factor, and then 2, find the remaining factors. Okay, so I can show that it's a factor. That's not hard to do. I'm going to do synthetic division here. And I'm going to take the x minus 2 that's here, and that minus 2, remember what's going to go in the window here? Good job, 2, because when you take it from x minus something, or a binomial, you take the opposite. Okay, the highest power is a 3 here. Do I have any missing terms? Nope. So then I'll do 3, negative 4, negative 9, and 10. So I know that in this location right here, that it has to be a 0 if they tell me it's a factor. Okay? So if I show that equals 0, then I have proven that it's a factor. So let's do that. So drop the 3. 2 times 3 is 6. Then add going down, negative 4 and 6 is 2. 2 times 2 is 4. Add going down, you get negative 5. 2 times negative 5 is negative 10. And 10 and negative 10 is 0. Okay, so what does that tell me? Right, I know that f of 2, right, that's because it's a 2 in this location, is equal to 0. So the remainder is 0. So therefore, x minus 2 is a factor. Are you guys okay with that? So that's the first part of the problem. The second part says that we need to find the remaining factors. Well, remember up here, right? We took 60 and then we divided it by 2. Do you remember that? And we got 30. Instead of going back to 60 again and finding another number that goes into it, we continued with 30. You see that? We're going to do the same thing here. So instead of going back to the original polynomial, let's work with the reduced polynomial. Because it has to be a factor also, which means this here is a factor, right, when I write it out. So let's write that out. So if you remember correctly, this got reduced from a third to a second. So this is 3x to the second power plus 2x minus 5 equal to 0. That we have to factor that, okay? Actually, it doesn't have to equal 0 because we're not solving it at this point. So I'm going to take and factor this. So 3x squared times negative 5, that's negative 15x squared. And I'm going to use my x here. I'm looking for factors that add to 2x. Isn't that negative 3x and plus 5x? Do you guys agree? So I'm going to rewrite this down here, but instead of writing the 2x here, I'm going to write it as minus 3x plus 5x. So we're going to get 3x squared minus 3x plus 5x minus 5. Okay, I can group, so I will. I'm going to group the first two, second two. What's the GCF of the first group? It is 3x, and we're left with x minus 1. Second one, I can take out a 5, and I'm also left with x minus 1. Are we all together? Okay, so what do these both have in common? They both have this x minus 1 in common, so I get to write that in the front. Okay, I'm going to, I'll write it over here. So it will be x minus 1 in the front, and then what do I take out? Once I reduce that, these both, oops, this one got it. They both reduce, right? And what am I left with? 3x plus 5. Now, if I multiply those together, right here, doesn't that give me these two? So it said find the remaining factors. We actually found the remaining factors. Those are the remaining factors. Okay, now sometimes in our directions, they'll say find all factors, or they'll say factor completely. In that case, you would still write the x minus 1 and the 3x plus 5. But notice too, you would also bring down, right, the x minus 2. So if I multiply all three of those out, don't I get the original polynomial? F of x, 3x to the third minus 4x squared minus 9x plus 10. The answer is yes, that's what we'll get. Are you okay with that? Okay, and then just really quick, because I think this will be good, and then we need to continue on with our notes. If it says find all zeros, sometimes they'll do this to you. Then what you do is you would take this here, which is x minus 1, 3x plus 5, and x minus 2, and you would set that equal to 0, and you would solve that. So then you would have here, right, x minus 1 equal to 0, so x is 1. Here you would have 3x plus 5 equal to 0. 3x is equal to negative 5. X is negative 5/3. And then here be x minus 2 equal to 0. I'm running it really small. Let's zoom in here. You'd have x minus 2 equal to 0, and x then is 2. And so our answer, right, would be that. Okay. So let's do one more example. Yes? Mm-hmm. Let's do one more example. Can I move this up? Are you still copying it? Okay. It says here, given f of x is equal to x to the fourth minus 13x squared plus 36, show that negative 3 is one of its zeros. Notice I didn't give you a factor this time, I gave you one of its zeros. And then factor f of x and find all its zeros. Oh my goodness. So there's a lot that it's asking for here. So let's go through and create my window here. So I'm going to take the negative 3 here, and you just put it in the window. So negative 3. It's the same because it's a 0, not a factor. Are there any missing terms this time? Yep, it's missing the x cubed. It's also missing an x, right? So this is the 1 here. Bring down those values. So it's 1. It's missing the x cubed, negative 13, 0, and 36. So drop the 1. Negative 3 times 1 is negative 3. Add going down, you get negative 3. Negative 3 times negative 3 is 9. Add going down, you get negative 4. Negative 3 times 4, negative 4 is 12. Add going down, you get 12. Negative 3 times 12 is negative 36. When you add those together, you get 0. So that means the remainder is 0. So therefore, negative 3 is a 0, right? Or we could also say an x-intercept. Isn't that cool? That's oftentimes why we find the zeros, is because they're x-intercepts, and it helps us in our graphing. Okay, let's take a look at the depressed equation here, see if it gives me any kind of clues. It was a 4th degree. I'm bringing this down to a 3rd degree. So that means this is 1x to the 3rd power minus 3x to the second power minus 4x plus 12. Okay, and I'll set that equal to 0. And I'm going to be like, is there a way to like solve this any further? Because they didn't give us any clues, so I can't use synthetic division again. But I notice there's 4 terms. It looks like it factors by grouping. So let's try that, which means I want this to be a plus sign here. So it's going to be x cubed minus 3x squared. I'll write plus negative 4x plus 12 equal to 0. So I'll group the first 2 and the second 2. What's the GCF of that first group? It's x squared, and we're left with x minus 3. And the second one, it's 4, and it has the leading negative, so I'll take out a negative 4, and I'm left with x minus 3. So I think that you can see now that those 2 terms have the x minus 3 in common. You guys okay with that? So what's the GCF? X minus 3. Divide the first one by x minus 3 and the second one by x minus 3. Those just become 1s. And so I am left with x minus 3 times x squared minus 4 equal to 0. Hey, wait a minute. Doesn't x squared minus 4 factor further? Isn't this the difference of squares? X times x, 2 times 2. So that becomes x minus 3 times x plus 2 times x minus 2. Now, if they are asking me to find the remaining factors, guess what? Those would be the remaining factors. That's not what they asked us for, by the way. They asked us to factor, right, and then find all at 0. So we're close to factoring, right? So let's just remind ourselves the relationship between zeros and factors. So the relationship between zeros and factors is the following. A factor is equal to x minus a 0. Okay, so we are given a root that we are given that negative 3 is a 0. Right? Given that negative 3 is a 0 in the original problem. So now what I'm going to do, so that's a truth, right? So that's way up here. If we just take a look, right? Negative 3 is a 0, right? They give us that in the original problem, so you see that there. So the next thing is that the matching factor for a negative 3 okay, is, now this is, remember the relationship up above right here is that you have x minus the 0. So this would be x minus a negative 3, right? Or what's that the same as? X plus 3. Now, if you were asked to factor completely, or find all factors, okay, then what you would do is, hang on here, perfect. You would take the factors that we have right here, which is the x minus 3, the x plus 2, and the x minus 2. Okay, and you would also take the x plus 3 from over here. And that would be factored completely. Now, again, what they ask for is to find all zeros. So that's what we're going to do now. So now, to find all zeros, set the factored equation equal to 0. Okay, and solve. So I'm going to take the x minus 3 times the x plus 2 times the x minus 2 times the x plus 3, and we're going to set that equal to 0. So either x minus 3 equals 0, so x is 3. X plus 2 is equal to 0, so x is negative 2. X minus 2 equal to 0, so x is 2. And x plus 3 equal to 0, so x is negative 3. And this here would be all zeros, which is what they actually asked for as the second part of the problem. But because of the relationship between factors and zeros, you have to be ready for what they might ask for, okay? And just understand that it really is the same thing, just communicated differently, right? Two sides of the same coin kind of an idea. Where one side of the coin is factor x minus 3. The other side of the coin, 3, right? Where that's the 0 that relates to the x minus 3. Are we clear? With that, that wraps the lesson.